Problem 5.3 reads, suppose we are to draw a random sample of 5 individuals from a large population in which 39% of the individuals are mutants, as in example 3.45. Let p hat represent the proportion of mutants in the sample. Use the results in table 3.7 to determine the probability that p hat will be equal to 0, 0.2, 0.4, 0.6, 0.8, and 1.0. Okay, so in this case, table 3.7 gives us the count. This is the probability that k equals 0, or that in our sample of 5, 0 of them are mutant. And here we have the probability that 5 out of 5. Okay, we can basically relabel all of these and just divide all of these numbers by 5. And here we have 0 equals 0.0. Here 1 equals 0.2, 2 equals 0.4, 3 equals 0.6, 4 equals 0.8, and 5 equals 1.0. So this column here is now our p hats, while this over here was the count. Okay, so in A, part I asks, what is the probability that p hat equals 0? The probability of this is equal to 0.08. Part 2 asks, what is the probability that p hat is equal to 0.2? That's just going to be straight from the table, 0.27, and so on. Probability that p hat is equal to 0.4. I'm just copying this table directly, almost. Whoops, p hat. So just remember that all of these are basically the same probabilities that apply to the counts also apply to our p hats. Okay, and then B just asks us to make a histogram. So instead of counts going across the bottom, we go from 0, 0.2, and this goes all the way up. Okay, so I guess 35 would go up there to there. So this 0.1, 0.2, 0.3, 0.08 goes up to here, and then 0.27. Okay, so technically this goes up to 0.27, which is a little bit higher. 0.27, 0.07 is down here, and then 0.01 is down there. Okay, so something like that for our histogram.